section 7.2. This is inverse functions and relations. So let's first talk about an inverse. You worked really hard, you completely organized and cleaned your room, it's perfect. And your little brother or little sister comes in and destroys it. Has that ever happened to you? All the time.
I just trash it.
Happens often in my house. So that's kind of like an inverse. You do something and then you undo it. We've talked about inverses in Algebra 1. What's the opposite of addition? Subtraction. Those are inverses. The opposite of multiplication is division. We're going to talk about inverses in terms of functions today. And there's kind of a special relationship that you'll see here in just a second with inverse functions and their graphs. And our goal today is to be able to find those inverse functions. So let's start with this. It says two relations are inverse relations if and only if, whenever one relation contains the element AB, the other relation contains the element BA. All that is saying is that these two are inverses. And I want you to take a look at the ordered pairs. The first ordered pair is 1, 5. Whereas in B it is 5, 1. Here it is 2, 6 in A, but in B it is 6, 2. We have 3, 7 in A, but in B, 7, 3. You see how there's this flip-flop, X and Y are flipped? Those are inverses. So I want to look at example 1 with you, and we'll do this together. It says the ordered pairs of the relation that are given are the coordinates of the vertices of a rectangle. Find the inverse of this relation, describe the graph of the inverse. Okay, so let's start by plotting these ordered pairs. Can you go ahead and do that? Plot 1, 3 on your graph. 1, 1, 2, 3. They should form a rectangle. We have 6, 3. 1, 2, 3, 4, 5, 6. 3. We have 6, 0. And we have 1, 0. I want you to go ahead and draw the rectangle in that's formed by these vertices. So I want you guys to see the connection to these ordered pairs and inverses. So let's generate the inverse. If this ordered pair is 1, 3, what would the inverse be? 3, 1. Write that down first of all. 3, comma 1. I'm going to put it in set notation. And the second ordered pair is 6, 3. The inverse of 6, 3? 3, 6. 6, 0 becomes 0, 6. 1, 0 becomes 0, 1. Those brackets, as a reminder, are just set notation. It's just how we write a set of numbers or ordered pairs. So would you please go ahead and plot these 4 new ordered pairs, these 4 inverse ordered pairs. 1, 2, 3, 1, 3, 6, 0, 1, 2, 3, 4, 6, 0, 1. Once you have those 4 inverse points plotted, draw in the rectangle. These 2 rectangles are inverses of one another. Now, I haven't mentioned it, but there's this random diagonal line there on your graph paper, isn't it? It's really not that random. It's there for a reason. Look at the points where these 2 rectangles intersect one another. There's 2 places, right? Here and here. Those 2 points of intersection also happen to be on this line here, don't they? That's not a coincidence. That will happen every time if you graph a function and its inverse. They will intersect along what we call the identity. This graph right here, go ahead and write this in. This is called the identity. We've talked a little bit about this. The equation for the identity is y equals x. Okay, y equals x is the equation of this line that was drawn in for you. When you graph a function and its inverse, those functions, those sets will intersect along the identity every time. Okay. So our goal today is to be able to graph a function, graph its inverse, and see that they do meet up on the identity. And we're not always going to have ordered pairs. Let's look at example 2 where we have a function to look at. Here it says to find the inverse of f of x equals negative 1/2 x plus 1, then graph the function and its inverse. Okay, so to make this happen, to find the inverse function, we have to go through a series of 4 steps. And I've got the 4 steps written out for you. Step 1, to find this inverse function, is to replace f of x with y. Okay, so I'm going to take out f of x, and in its place I'm going to put y. So y equals negative 1/2 x plus 1. That's step 1. And you can put it under step 1 there on your notes page. Under step 2, it says to interchange x and y. So what I'm going to do is I'm just going to flip-flop places of where I have x and where I have y. So I'm going to, instead of y, it's going to be x equals negative 1/2 y plus 1. In step 3, it says to solve for y. So I'm going to take this newly created equation and I'm going to solve for y. I'm going to do that on the next slide here. So we have x equals negative 1/2 y plus 1. How can we get y by itself? Subtract 1. Let's go ahead and do that. I'm going to subtract 1 from both sides. So I have x minus 1 equals negative 1/2 y. Now the reason I'm solving for y is because I'm ultimately going to want to graph this. So let's get y by itself, put it in slope-intercept form so we can graph it. Now what would I do to get y by itself? I don't want to divide by a fraction. What do I want to do? Multiply by negative 2. So I'm going to multiply the right side of the equation by negative 2. And I'm going to multiply the left side of the equation by negative 2. So we'll distribute the negative 2. We have negative 2x plus 2 equals y. I'm going to flip this around and say y equals negative 2x plus 2. And the very last step, on the very last step there, I want to replace our y with this. This reads f inverse of x. All it means is this is the inverse function. That's it. But it's a notation we're going to use. So f, we don't say f to the negative 1 power. We say f inverse of x. And it's equal to negative 2x plus 2. So the cool stuff doesn't happen until we graph. I want you now to graph the original function, and I want to graph the inverse function. So you've got graph paper there. So the original function, let's try to put down, f of x equals negative 1/2 x plus 1. And the f inverse function is negative 2x plus 2. Okay, so go ahead and graph if you haven't already. They're both in slope-intercept form. We can graph them. We have a y-intercept at 1 and a slope of negative 1/2. When you're ready to graph the second function, the inverse function, we have a y-intercept at positive 2, and the slope is negative 2. So down 2 and right 1. Down 2 and right 1. Up 2 and left 1. We'll draw on our graph. So like we graphed those rectangles a second ago, these two lines should intersect. And they should intersect right there on that identity. And they do, don't they? If they don't, that's your clue. You either graphed it wrong, or maybe you found your inverse function incorrectly. So we found our inverse function and we graphed, and we could see that that point of intersection is along the identity. Now I don't need that point of intersection. It's just kind of cool to see that that really does happen. Flip over to the back side if you would, please. Let's look at example 3. It says find the inverse of the function, then graph the function and its inverse. So let's go through those 4 steps and find the inverse function. What's the first thing it said to do on the front side? What was step 1? Replace f of x with y. So we're going to say y equals 2x minus 5. What was step 2? Interchange x and y. So you're literally just going to flip-flop where x is and where y is. Step 3? Solve for y. How would you solve for y? 5. So I have x plus 5 equals 2y. Then we can divide by 2. So I'm going to have y equals 1/2 x plus, I could leave 5 halves as 5 halves, or I can make it 2.5, it doesn't matter. And the very last step, we often forget that one. What do we need to do with that y? What do we call that? F to the negative 1, how do we say that? F inverse. We're going to change it to F inverse equals 1/2 x plus 2.5. I don't want you to forget that last step, because that last step is telling everyone who looks at your work that that is the inverse function. Alright, so if you would, please go ahead and graph both of these functions. I'm going to graph the original function first. The original function has a y-intercept at negative 5. I'm going to go down 1, 2, 3, 4, 5, and the slope is 2. Rise 2, run 1. Rise 2, run 1. Could also go down 2 and left 1. Now when I graph the inverse function, the y-intercept is at 2.5, so up 1, 2, and halfway. Okay, no big deal that we have a decimal for a y-intercept. And the slope is 1/2. So I'm going to go up a full unit and over 2. Up a full unit and over 2. Up 1, over 2. Up 1, over 2. Could also go down 1 and left 2. Now I'm going to draw in my identity graph. If something happens and your graphs don't intersect along the identity, you're off, aren't you? Either your function was incorrect, your inverse function was incorrect, or your graphing was off. So they should intersect along the identity every time. Let's look at example 4 real quick. We'll do one more. In example 4, we have the function f of x equals 3x plus 9. What's the first thing we're going to do in putting this into the inverse function form? Replace f of x with y. So y equals 3x plus 9. What do we do next? Interchange x and y, so switch your x and y placement. And then solve for y. We'll subtract 9. So x minus 9 equals 3y. We'll divide by 3. So we have y equals 1/3 x minus 3. And the last step, which I don't want you to forget to do, what are we going to do there?
Inverse of x.
Right, make it the inverse function. So f inverse of x equals 1/3 x minus 3. So then let's take a second and graph. So my y-intercept of the original function was a 9. And my slope is 3. I'm going to go down 3, 1, 2, 3, and left 1. Down 3 and left 1. For the inverse function, I have a y-intercept at -3, 1, 2, 3, and the slope is 1/3. So I'll rise 1 and run 3. Rise 1 and run 3. Could also go down 1 and left 3. I don't have my inverse, or excuse me, I don't have my identity drawn in yet, so I'm going to do that next. If you're graphing on your own for your homework, I would encourage you to draw in that identity graph because I think it just confirms that we've got things in the right spot. We've got our function should be correct. Everything should be graphed correctly. So today we really did two things. Let's go back through some things that we did. We looked at ordered pairs, we call that a relation, and we found the inverse of that relation. How do we find the inverse of a relation? Just switch your x and y, that's all. Okay? Next, we looked at the 4 steps for writing a function into its inverse. What's the very first thing we're going to do if we're given a function and want to find its inverse function? Replace f of x with y. What's next? Switch your x and y. Step 3. Solve for y. And then step 4, that we always forget, write the inverse function, f of f inverse. Now again, when you graph it, where should your lines intersect one another? On the identity. If they don't, something's up, isn't it? Okay. Alright, so today's assignment is out of your textbook. I printed some graph paper for you. I did not draw in the identity. I would encourage you to draw in the identity as you work through these problems. You check your graph.